Why me? You don't even know me.
Because what I've seen, I've liked. And I got a good feeling about you.
And on the count of three. It's only one in your dreams.
Make a wish. 1111, make a wish.
Welcome to today's Chapter 2 review of CCNA Study Lab with your host, Joe. Alright everybody, I want to thank everybody for watching because yesterday's, I want to kind of apologize. There was probably about a good hour gap. I didn't want, what had happened was I set up the schedule yesterday, and I kind of just wanted to just get on it at the time I said was going to get on it, but I had an important phone call come in at the exact same time when I started, so, it was, I had, both hands full at the same time. I tried to obligate both obligations that I set for myself, foot into mouth type thing, but today, we're jumping right back on the horse. Like I said, I'm gonna continue to continue the stream weekdays at 5 o'clock Eastern Standard Time. So I'm super happy if you guys love, if you guys can join me live, that'd be great. If the music is too loud, tell me if the music's too loud, guys. I can turn it down. Let me just turn it down just a little bit. Today though, we're gonna cover chapter 2 of the CCNA the 200-301 official cert guide. The book itself, guys. The book itself, it's by a great author, Weldon Odom. And you guys can, if you guys are interested, hit me up in the chat and I'll tell you where you can find his website. He has a great website, and he's put together a lot of labs in Packet Tracer. And if you guys are interested in Packet Tracer as well, because I believe Packet Tracer is a great way. If you are starting into your CCNA studies, Packet Tracer is one of the best tools you can use to get that hands-on type of learning. For me, hands-on learning is very important to kind of put the mechanics behind the text that I'm learning. That's crucial for how I can digest a lot of this information. Without starting with Packet Tracer, I don't think I would have been able to get even, as far as I've gone so far. I'm not gonna say I'm not an expert. I'm learning with you guys. That's what it's all about. I'm still tracking on getting my CCNA associate's certification. This is the path that you guys are gonna be. I'm taking you guys live with me on my study journey to go after that, because I'm gonna try to do both. And I was also thinking tonight, if you are watching me live, I'm gonna probably be setting up a schedule for DevNet review too, because I want to cover the Cisco certified DevNet associate. That's the Dev ASC 200-901 certification. All right, that's this certification right here. This is the official cert guide for that cert too as well. That covers a lot of the DevNet. This is, obviously the CCNA, super important. Fundamentals, all right? Fundamentals, okay? I have to learn this. I'm gonna learn this at the same time, all right? I've already dived into Python coding, learning Python and, and messing with Ansible and Docker and stuff like that. That's what led me to getting into EXI servers, and which then eventually end up me jumping into Cisco Model Lab. All right, Cisco Model Lab. It's the next step. I wouldn't suggest, and I'm not going to push anybody to jump on to getting into Cisco Modern Lab. You can use Cisco Modern Lab. The DevNet team at Cisco, they actually have it where you can set up you can reserve a time frame that you can actually go on their website and then utilize one of their servers. You'll have to VPN into it, but you can actually use Cisco Modern Lab, which is, if you've seen my streams before, that's what I use heavily when I do a lot of this lab and stuff like that. I love Cisco Modern Lab. I found a lot of quirks and stuff like that with Cisco Modern Lab. But at the end of the day, it's great. It's truly, it truly is like real hands-on. If you can get real, is it? Yeah. Okay. So the music is too loud. All right. Thank you. Good looking out. Let me take care of that right now. Then. If that helps. If it's still too loud, guys, I'll just turn the music off. Actually, let me put this back to where I had it, and then so I don't mess with my levels. I can still hear it a little bit. That's good. Tell me how that is now, guys. Thank you very much. Appreciate that. Yeah, so so this is what you you guys can't even, I don't even have my it's a little too quiet but good. Adjust that just a little bit more. I gotta find the right level for how this is, because what I'm using is I'm using Twitch's beta. That's good. Okay, thank you very much. I'm using Twitch's beta soundtrack. Yeah, they got a new music service. What it's gonna do is you guys will hear this in the live stream, but on the recording afterwards, they delete it somehow. It figures out how to delete all that music. It pretty much removes that music file from the live stream when it gets recorded. That way I don't get in trouble with copyright strikes and whatnot. So I love it. You know, I'm happy they did that. You know what I'm saying? That way, you know, it's nice to have, you know, that ambient music in the background. Adds in an element to the stream. Is it even playing music anymore? There it is. Alright. Getting worried that I wasn't even playing music anymore. Ah, there we go. Thank you again. Appreciate that. Alright. Yeah, so like I was saying, hit me up in the chat if you're at any time, hit me up in the chat. I am here to answer your questions. That's what this is about. It's all about learning, guys. And I want to build a community around learning, okay? You know, but I want to have fun with this as well. So without further ado, let me get some coffee. So if you got coffee, time to get coffeeed up. All right. Beep, beep, beep. I don't know how y'all take your coffee, but I think the only way to drink coffee is black. The only way to drink coffee, in my opinion. Other than that, you're drinking sugar water. Love it. I love it. Ran out of the good coffee. Had to break out the Stop and Shop coffee. It's still good. Any coffee is good coffee, in my opinion. All right, guys. All right. So, kind of like what I want to do, since we went over chapter 1 yesterday, what I want to do today is I got the Pearson test prep lab up, and what I want to do as we review, as we jump into each chapter, what I want to do is the next day on the next stream, we're gonna go back, we're gonna review the previous chapter on the Pearson test prep. Okay, so the Pearson test prep program, that's like when you go to take this actual certification, you're gonna take it through Pearson. And at the end of it, what we'll do once we get to near once we finish this whole book right here, we'll do a whole entire volume 1 review. Okay, all right. So that'll be, we'll make a date for that whole entire review, and then once we get into volume 2, we'll do a whole, entire volume 2 review. And then at the end, we're gonna have to take, the whole stream will actually be going through the entire exam. All right. And this is a great program. I can set it up to ask as many questions as possible and make this as hard as possible. And the point to this is to get ready for the actual exam. So what I've done to kind of just get us set up for this real quick is we're just going to review chapter 1 now. Chapter 1, like if you caught yesterday's stream, that's the introduction to TCP networking. And I believe by just selecting these two, it's just going to give me I believe it's only going to give me 25 or 30 questions on it. It might even give me less because it only has, because I've done this a couple of times over a couple of iterations, and with some of the earlier chapters, it only has so many actual questions. As the chapters progress, especially for the subnetting, it has endless subnetting questions for days. Subnetting's a whole bag of. We can talk about subnetting for 3 months. That's subnetting. It can always confuse you. So, take a sip of coffee. Coffee time. Alright, and we can actually add some more parameters, but we're not going to get into all that. Right now, we're going to have it just straight in study mode. We're going to jump right in. Alright, which of the following terms represents an L3 PDU in the OSI model, which includes network layer header in its encapsulation? That word, man. That word. I hate that word. My speech impediment cannot say that word. All right. So a layer 3 PDU. Okay. So if we remember yesterday, I just had my marker. There's my marker. All right. So if we remember yesterday on the OSI model. All right. That's the 7 layer. All right. Remember, don't be confused when it goes back and forth through the TCP and the OSI model. Okay. So in the OSI model, like we reviewed yesterday, all right, I'll do this so I'm accurate and precise on this one. Okay. Actually, I'm not gonna look in the book. Let's not look in the book. Let's just go off of head. Okay. So right here, so 1, 2, 3, 4, 5, 6, 7. I believe this was. I know for sure. Right here, it's gonna be packet. All right, because over here you have IP, all right, and then up here this is transport, all right, so you have transport, and then this is number 5. Number 5, I believe that's, yeah, so 4 is actually, it's transport to segment as well, all right, IP packet. So frame, because this is dealing with MAC addresses, all right, on the layer 2, and yeah, data, whatever. So layer 3, we're gonna pick packet, right? Yeah. Hello, what's up? Yeah, that's how I can never say that word. What's up, Detox Mango? What's up, Fuzzy Moogle? How we doing? All right, so let's go on to the next question. IP functions at what layer of the OSI model? Okay, so again, IP functions at the network. All right, the network layer in the OSI model. Similar again, so. Remember, so we'll say TCP is the 5 layer. All right. So we're going to select network. All right. The term segment refers to which layer PDU. Remember, segment is transportation. All right. So that's TCP, and UDP. All right. So that's the transportation. Wow, it only gave us 3 questions on that one? How'd we do? Woo! We scored 1,000! Man, that's too easy. All right, but that's how we're gonna do the beginning of each stream. We're gonna review each chapter from the previous chapter that we reviewed. Okay. What I do? Yeah, we'll quit out of this. All right. So, any questions on that review so far? I have been reading malware papers, but I have not studied networking or CCNA textbooks because I did not go to UNI. If you can give me a little bit of context on UNI detox, I would love that. Reading malware papers. I haven't. So you got a little bit of leg up on me. I haven't. Oh, university. Go to university. Okay. Yeah, I haven't. I took a great class the other day. So you're gonna be. So I'm using. I have a subscription to OReilly, and that's how we're gonna be reviewing a lot of these things. And through that subscription, I get the opportunity to take a lot of live courses. And I took a live course. It was about a week or two ago. And here, I'll go to his website. It's a great website. Omar Santos. There you go. Yeah, I'll throw this in the chat too, guys. I have learned many networking low-level stuff, but when I open CCNA textbooks, yeah, it's a lot. It's definitely a lot. The CCNA. So I'm starting at the CCNA level now, and that's what they've done is they kind of, if you're kind of aware with the networking on well, at least how Cisco certs have been working. Their older model on a lot of like their associate level certs was kind of like pretty vague. It was kind of spread all over the place. What they've done is they consolidated a lot of that into the CCNA associate cert. And I tell you, there's a lot in the CCNA level. From networking fundamentals to APIs to they touch on even topics like Ansible and Docker now, which I'm surprised. And that's it's for me. What I'm gonna do is I'm gonna jump from CCNA to DevNet and then go to CCNP from there. And that's kind of like the track. I feel I'm gonna have the most benefit with, especially with the DevNet stuff, man, with automation, Ansible and stuff like that. And if you follow some of my stuff, this is Cisco Modern Lab right here, and I've been mocking up. I got a couple mocked up labs with Ansible controllers and whatnot. I have some fun, and I was gonna try to get into some pen testing stuff with this, but I still gotta narrow down my focus back down to the CCNA level stuff. I am curious. The average CCNA will not have. For example, and the 4 days which was used. Yeah, I'm. Throw me throw a link in the chat, man, or something. Yeah, I haven't done too much with like I said, I haven't done too much with malware, pen testing, or anything like that yet. That's eventually down the road where I obviously I need to learn that stuff because it's super important. Oh, it's super important. I get it. Right. Yeah. Yeah. Yep. You're right, Buzzy Moogle. Alright. Let me close some of this down since we've already reviewed that stuff. Alright. So what we're gonna do now is it's probably is the sound too loud again? Alright. Sorry about the. Give me 1 second, guys. I'll lower that a little bit. Alright. That'll probably take, hopefully after this stream I'll have the sound levels on the music at the right level. With OBS, I use OBS as the streaming, and that right there is the new Twitch. From the CCNA validation, your skills and knowledge, environmental, IP, connectivity, security, fundamental, automation, and programmability. Yep. Yep. Detox. I tried skimming through the Zeus and the WannaCry. Yeah, be careful with all that. I don't know if you. The best way to do a lot of this stuff is to make sure you're doing this all on VMs, especially if you're touching virus and stuff like that. That at least what I got. That was the takeaway that I got from Omar Santos's class. You don't really wanna start messing with that stuff on your prime machine or your main machine, stuff like that. Just be aware of that. Even using VMs when you're doing some. This is again what I'm getting from Omar Santos. He stressed. He couldn't stress it enough that you want to take that stuff totally off of your network, totally off of your main machine and whatnot. So let's continue on. Let's take a sip of coffee first. Water my bill. All right. Chapter 2, Fundamentals of Ethernet LANs. All right. Chapter 2 covers the following exam topics. All right. Network fundamentals exam. Explain the roles and functions of network components. L2 and L3 switches describe characteristics of network topology architecture. Small office, home office, SOHO networks. Compare physical interfaces and cabling types. Single mode, multi-mode, fiber, copper, connectivity. Excuse me. Most enterprise computer networks can be separated into two general types of technology: local area networks, LANs, and wide area network, WANs. LANs and WANs. Yeah, there's some good ones out there. There's a lot. Like I said, Detox. I go through OReilly Media for a lot of my knowledge. And if you're interested in stuff, and if you really are serious about that stuff, I would suggest taking some of their live courses and whatnot, and getting it from the guys, from the sources themselves that deal with that kind of testing on a daily. So we're just gonna go over LANs and WANs. LANs and WANs. All right. Local area networks. All right. Wide networks. All right. Little line here. So a local area network, a LAN network, obviously, that can be as easy as you got your home router, you know what I'm saying? / Wi-Fi router, your wireless router. you got a couple PCs, a couple smart devices, you know what I'm saying, that's hooked up through Wi-Fi. You know, maybe you have a smart, you know, a couple smart devices. And this could be, you know, what the general thing is everything's pretty much connected all to one source. And then obviously you got it's all going to your ISP, but it's all in the local area network. You know what I'm saying? For the most part, you only got one subnet that you're dealing with, for the most part. So by putting my experiences I have reading papers in my resume could get me a job as a network engineer, and I could learn the rest on job. Yeah, I mean, you probably, you know, I would suggest, you know, anything you're putting on your resume is always good. As long as you're able, but I would stress though, learning the fundamentals. You know, it's one thing to, you know, I don't know, I stress the fundamentals of all this stuff. And I guess in my perspective, and this is just my perspective, is you gotta know how, you know, I guess the lower level stuff works before, you know, the higher level stuff works. I don't know. You know, pen testing has its place. I would go after pen testing. You know, there's probably positions just strictly for pen testers now. I believe there are, and if I believe that's an actual separate route itself. You know, for me, I'm not a network engineer. You know, I'm striving to be that. You know, I'm actually looking for on-the-job opportunities right now to learn this stuff. You know, so we're going to wide area networks. All right, wide area networks is when you're dealing. Obviously, say you have Mr. Corp office over here. All right, you got a couple satellites. All right, so you have Corp office, and then, you know, we'll say this is the Home Depot Corp office. All right, this is just the Home Depot in, you know, who knows, Ohio. All right, and then you have, you know, Home Depot and, you know, whatever, Mass. All right. The point of the wide area network is even though these are their own lands, they all have to communicate back their information to the corporate office. All right, that's what is making the actual wide area network, and that's what creates that type of topology right there. So that's just, you know, a little bit of how the terminology works to kind of put some context behind the words. This is how it's helped me to put it all in perspective. All right. So let's move down. So what we're gonna do is we're gonna review the "Do I know this?" quiz already. And this in the beginning, why are all these highlighted? Remove, you crazy highlights. You're gonna give me a hard time. Oh boy. I don't think I have them all. Yeah, it's just those. Just some random highlights that I must have left on here from who knows when. Alright. I don't want to take off that highlight. There it goes. Alright. Let's try that again. Sorry, another one right here. Don't mind these highlights right now. These highlights, honestly, I don't think they were never right in the first place. Alright. Alright. So we're gonna start right here on the first question. In a LAN for a small office, some users devices connect to the LAN, the local area network, using a cable, while others connect using wireless technology, no cable, Wi-Fi. Which of the following is true regarding the use of Ethernet LAN. Get my handy dandy Mr. Maka. All right. So if we're thinking about cabling, so in cabling, we're not going to be, obviously, this, whoa, that's too big. All right. So obviously, it's giving us a hint, no cable. All right, so if we're going down the answers, only devices that are using Ethernet cable, so A. What are the other ones? Only devices, and you're absolutely right. So we're gonna say right here, number 1, A. That real quick. All right, let's go down to number 2 now. Which of the following Ethernet standards define gigabit Ethernet over UTP cabling? No idea for number 2. So, I know this. So it's gonna be, so you have 10 gigabit, 100, and 1000. So if we're thinking gigabit, we gotta think size of information. All right. So size of information. That's what we gotta think with gigabit. And you're right. It is C. All right. So we're gonna go with C. All right. Let's go down to number 2 now. Number 3. Which of the following is true about Ethernet crossover cable for fast Ethernet? Now this one right here, I always get messed up on crossover cable and then straight through cables. For some reason, I haven't yet really nailed it down. I think it's partly to do that I haven't handled the physical cables yet, and I haven't manipulated them with my bare hands yet. I believe once I get to actually cutting cables and then threading the RJ45 adapter on them, then I'll probably be able to put this more in perspective for my own mind. Like I said, I'm a very hands-on type learner. But for 3, so I'm gonna say, so A, pin 1 and 2 are reversed on the other side of the cable. I don't think so. Pin 1 and pin 2 on one end of the cable connect to pin 3 and 6 on the other end. And then, but this is fast Ethernet. So this right here is a clue too on what we're trying to answer. Yeah, you want to go back up to 2? I'll go back up to 2 for you. So which of the following Ethernet standards define gigabit Ethernet over UDP? All right. And I'll give you the breakdown real quick. Okay, so 10 megabytes per second over Ethernet. All right. 100 bytes per second. All right, 1,000 megabytes per second. Got the P in there. So we got fast gigabit. All right, so this is just regular Ethernet. Then you get into 10 GBS, gigabytes per second. So gigabytes per second. Then you get into the range of 10 gigabyte per second. 10 gig, 10G. So that's 10G right there. This is 1G, obviously. And then you get into like the different, so you're getting it. So it's all about how much information is actually going through the actual physical cable itself. So that's how that's obviously how it breaks down right there. I appreciate your curiosity, man. I thank you very much. I love it, man. All right, get my handy dandy. So we were just going through 3. So question 3, which of the following is true about Ethernet over crossover cabling? Again, I don't think it's A, I don't think it's B. I believe it is C. Cabling, yeah. So pin 1 and pin 2 on one end of the cable connect to pin 3 and 4 on the other end. I'm kind of on the fence though with B and C. I'm gonna go with B. We'll go with B. Let's see what happens. Now let's go to question 4. Each answer lists 2 types of devices in a 100 base T network. If these devices were connected to UDP, if these devices were connected to a UDP Ethernet cables, which pairs of devices would require straight through cabling? All right. Now this is because of how these devices are actually processing information. So on some devices, the transport and the receiving ports, it can't distinguish, it doesn't separate that actual information. So that's what this number 4 question is asking. And that's the reason why this crossover and straight through cabling. All right. So we're gonna come over here, question 4, and it's asking for 3 answers. So PC to router, I believe is crossover. PC to switch, though, I believe is straight. So we're gonna put B. Hub to switch, no. You gotta think hub to switch. They're almost like the they're almost doing the same thing. A switch is just it used to be a bridge, which a hub is pretty much a bridge. You're googling this. So router to hub, though. Again, a router is similar to like a PC, so I'm gonna say D, maybe. And then wireless access point, Ethernet port to switch. I'm gonna say E. So we'll say B, D, and E on question 4. All right. Which of the following advantages of using multimode fiber for Ethernet link instead of UDP or single mode fiber? All right, so A, it's to achieve longer distance possible single link, to extend the link beyond 100 meters while keeping the initial cost as low as possible. I believe it's B, but I'm going to read the other ones. To make use of the existing stock of lasers. No, I don't think it's that. To make use of the stock of, no, I don't think it's that one either. And then, yeah, so we're going to say question 5 is, so we're going to say 5 is B. To extend the link beyond 100 meters, all right, while keeping the initial cost as low as possible. We're going to go over this terminology as we review the chapter and stuff like that. Because the chapter goes into explaining all of this. This is the pre-questions to the whole entire chapter. So this is just trying to see how much you know about this chapter. That's all this is. Again, I'm reviewing this. I've gone over this. I probably went over this months ago. I haven't been on this topic for a while, so I'm kind of rusty. So that's why I gotta. I just said hi to myself somehow. That must be my boys on the Xbox in the other room. They were. So Let's go on to question 6. Which of the following is true about CSMA CD algorithm? So collision sense management algorithm with collision detection. So I believe hey Joe, stop. This is O'Reilly Media. So if you want the exact, so I'm using the CCNA 200-301 official cert guide, detox, if you're curious. All right. So the algorithm never allows collisions to occur. Now it doesn't. Collisions still occur. So collisions can happen, but the algorithm defines how the computer should notice a collision and how to recover. I know it's B, because that's what the algorithm does. It doesn't stop the collisions from happening, and we'll once we get into the chapter, it's gonna better explain how it detects that, and then how it resends the information once the collision has happened. All right. Newer networks and how networks work now, it's kind of it's the Cisco book. This is an official Cisco cert book, but I have the I'm using I pay for the O'Reilly subscription, so even though I have it hard, I have it digitally as well. So and it helps me review, because there's a lot of other benefits with having the O'Reilly subscription, because of the live training and stuff like that I get. But yeah, let me see. It's if you just go on, I believe it's just O'Reilly. Let me bring it to their yeah, man. That's a great book too. The routing and switching book. But again, this is what on the CCNA level, it's still, it's going to introduce you to a lot of those fundamental topics. But yeah, if you're ready for the CCIE level, go right at it, man. And I believe now with how Cisco's revamped their search structure, they allow you to just jump right into the CCIE levels too now. I believe so. But you gotta make sure you lab up hardcore for the CCIE levels. A lot. At least from my exposure so far, with talking to times. Yeah, I mean, you can. Have you had any experience with GNS3? I got GNS3. I got GNS3 up on my right here on my EXXI server too. Again, I think GNS3 is great. I love it, but I obviously use Cisco Modern Lab. So the thing is to be able to actually lab up in GNS3, you're gonna have to purchase the subscription for Cisco Modern Lab. There's no way around it, just because you're not gonna be able to get the ISO images you're gonna need, because the only way to use GNS3 is you need to import your own ISO images in there. Now there's some Docker images, but those are just Linux Docker images. I mean, yeah, you can. I mean, if you used VMs before, you can make whatever you can boot up any Docker image you want, or any Linux image you want. Linux is free. The Cisco images though, those ain't free. You gotta pay for those images. So, I like using GNS3, but I find using Cisco Modern Lab, the images just work a little bit better. And they've done some serious updating to it. And this is it right here. This is the new 2.1 version of it. It's a $200 subscription a year. If you really want to go after CCIE, you should probably think about it, but start with Cisco Packet Tracer first. Cisco Packet Tracer, you can do labs for days to get you almost where you need to be with your CCIE level stuff. But once you get into a lot of the Linux stuff and stuff like that, you're not going to be able to do a lot of that stuff inside of Cisco Packet Tracer. Cisco Packet Tracer is a Alright, so funny story. So Apple bought the terminology ISO from Cisco. Cisco owns the terminology ISO. So yeah, I know when I say ISO, you think iOS for iPhone and whatever. But iOS it's a Cisco proprietary in how they call their images. So so that's a little bit of yeah. So iOS obviously Apple, but now that I've been diving head first, my brain is now, it's all about router, Cisco, Cisco everything. All right, where we leave off. So we're on question 6, and like I said, I believe question 6. We're gonna say B for question 6. All right, we'll move right down. Which of the following is true about Ethernet FCS fields? So, A, Ethernet uses FCS fields for error recovery. Nope. It's 2 bits long. Nope. It resides in the Ethernet trailer and not the header. I want to say it's C. It is used for encryption. No. So for number 7, we're gonna go with C. You gotta. We're going to go over to 8. Which of the following are true about the format of Ethernet addressing? Choose 3. All right. So this is covering MAC addresses. So a MAC address is a 48-bit. All right. MAC address is a 48-bit address. All right. All right. So what is A? Each manufacturer puts a unique OUI in the first 2 bits of the address. Nope. Each manufacturer puts a unique OUI code in the first 3 bytes. So first 3 bytes, 1, 2, 3. So we're gonna go with B. Each manufacturer puts an OUI in the first half of the address. Part of the address that holds the manufacturer called the MAC. Part of the UI. So we're gonna go with C. And then the part of the address that holds the manufacturer code is called the OUI. So we're gonna go with E. All right. So for number 8, we're gonna say A is B, C, and E. All right. And then number 9. Which of the following terms describe Ethernet addresses that can be used to send one frame that is delivered to multiple devices? All right. So we got to think what kind of address is going to go to multiple devices. Multiple. Again, a lot of these questions, they kind of hide, they kind of give you hints on what they're asking. All right. So we're thinking multiple addressing. Come on, you're getting crazy on me. That's why it got wet. All right. So we're not thinking burned in. Unicast, Yun. You think one when you think Una. All right. So broadcast and multicast. So we're gonna say for number 9. We're gonna say for number 9. We're gonna say C and D. Now let's check on our learning. See how we did. See if we got any wrong. I might have got something wrong. So 1. Let me change that color. So we're gonna say 1 A. Yep, we got that one. 2 C. Good. 3 B. We're good. 4 BDE. Cool beans. We're doing good. And I'm gonna say 5 B. 6 B. 7 B. 8 BCE. Cool beans. And then 9 CD. All right, so we did pretty well. Thank you for your help too, Detox, man. I appreciate that. All right. Perfect score. Ooh, yeah. All right. All right, now we're going to get into reviewing the actual chapter. And then this is where it's going to elaborate, and we'll stop. And then when we come up to key topics, we'll spend some time. We're going to spend some time discussing the key topics. That way we kind of hammer down the information that we're going to need. But I definitely need some more coffee. Coffee. Did you go on that Omar website? If you went on Omar Santos's website, like I said, I'm not in the world of pen testing and stuff like that. That whole globe of stuff. Refer to Omar Santos. He's actually written a book. It's a new book too. That Omar Santos, he just wrote a Cisco book about security. So if you're getting any source information from him, he's the guy that you should believe and take his word on. I'll go back to his website too real quick. I don't want to get too off the topic, but we'll explore it real quick. We'll explore it real quick while we're here. Like I said, I took one of his initial courses. It was real high level. It was high level stuff, so he didn't get into any really nitty gritty stuff. But go on his GitHub. His GitHub is great, man. I went. He's got some great stuff up on his GitHub. Yeah, I'm telling you, get on there, dude. There's a boatload from Python to everything on there. Yeah, hook up on there. He does some, like I said, he does some high level training as well. He right now, he was just, he goes through a series of courses, and he might be probably getting towards the really nitty gritty lower level deep stuff right now. But yeah, he's top notch when it comes to pen testing in that field. All right, he's the guy to definitely follow up on. All right, so again, let's continue on here. The term Ethernet refers to the family of LAN standards that together define a physical data link layer. The world's most popular wired LAN topologies. The standards define the institute. So the IEEE, very important. The IEEE. I mentioned this yesterday. IEEE, they pretty much provide the standards with RFCs. So when you see RFCs, all right, request for comments, all right, when you see RFCs, request for comments, you think IEEE, all right. They create the standard. Cisco though, because they've been in this game for quite some time. You'll see a lot of their proprietary standards get copied almost by the IEEE, but then once IEEE creates the RFC for it, Cisco will then incorporate that RFC back into their standard, and then they'll pretty much do away with their proprietary and go with the RFC, just because Cisco is coming to terms with the fact that there's other players in the game, and the only way to make things work now is to make sure everybody is using one standard. All right, that's kind of like we covered about yesterday with the OSI, the TCP/IP model, and stuff like that. It's all about everybody coming together to make sure they're using one type of standard, and that's why Linux is taking over the it's pretty much taking over the world right now. You got Linux subsystem for Windows now, which I believe is awesome. I don't use it, obviously, just because I can, I boot up whatever VMs I want natively. But if you don't have the ability, or the computer, say your computer can't virtualize on computers, you don't have the CPU to do it, you can download Linux subsystem right off the Windows Store and just start playing with Linux. I suggest that for anybody. Just be careful though. I mean, you could still delete stuff from there. Yeah. Oh yeah. I made my first website just recently, actually. It's not that great. It's all right. JoePress.com. I started off as just a blog. I've gotten, like I said, I've gotten into HTML, how to make websites, Python, JavaScripting, and whatnot. That's why, like I said, once I get past the CCNA level, I'm going straight to DevNet level. My whole thing is I need to get better at incorporating APIs and how, and utilizing APIs because everything's going to be a web-based application. Everything is going to be a web-based application soon. It's just the way the world is turning. Software as a service. Everything, like, here we go, Cisco Model Lab. I'm using, everything's over here is it's all web HTML. This is all through even my server. It's all web, HTML. It's the way of the future. Well, it's the way at least everything's going right now. Papers, books, case studies, so I'm confused where to invest more time. honestly, pick one thing, man. Pick one thing and kind of stick with it. But you gotta figure out really what you want to do with it. You want to do pen testing in malware. You really want to get into malware and stuff like that. You gotta learn Linux. You gotta start with Linux. If I could suggest you to do one thing, download Ubuntu, well, I would probably, for you, I would probably go with Fedora or CentOS, just because that's Red Hat Enterprise Linux. Ubuntu's great. I love Ubuntu. I prefer using Ubuntu over using like Fedora and CentOS, but you're gonna run into everybody like Amazon. Everybody uses Red Hat Enterprise Linux, which is Fedora, which is CentOS. Fedora. So here, I'll kind of give you. But I do play with Raspberry Pi. So Raspberry Pi. Yeah, so Raspberry Pi is Ubuntu. All right. So if you have a Raspberry Pi, that's Ubuntu. All right. But over here is Red Hat Enterprise Linux. All right, RHEL. So when you see the terminology RHEL, that's Red Hat. All right. So that's Fedora, CentOS. All right. Fedora, CentOS, and come on, use my noodle. There's one more. Why isn't it coming to me? Yeah, whatever. But Ubuntu over here. Ubuntu. You'll get the Raspberry Pi. You'll get just Ubuntu. There's a couple other ones. But then you have other flavors of Linux as well. Kali, yeah, I believe Kali Linux is a version of Ubuntu as well. Yeah, I mean, there's so many different flavors of, so we'll kind of just make that divide over here. You know what I'm saying? It all natively is Linux, but you'll have your primary players, which are these two primary players. You got your Ubuntu camp, your Red Hat Enterprise Linux camp, and then you got other ones. There's so many, and then there's so many. You can make your own version of Linux if you want. You can make your own OS. Is it gonna work? It might. It will work for whatever application you want it to work on. You know what I'm saying? If you're smart enough. I take a lot of if you take a deep dive into Linux, I take a lot of courses from Sander von Wundt. He's a Norwegian fella, and he pretty much wrote the book on the Red Hat Enterprise Linux certification. And actually, next week I have a live course with him. I actually had a course with him today over Bash. What was it? Today and yesterday, I had two courses with them over Bash scripting. That was pretty fun. But yeah, if I was you, definitely spend some time taking a deep dive into Linux. You're gonna have to learn it. Linux is the most important thing you will ever learn. It's the world operates off of Linux. AWS runs all off of Linux. Cloud computing, Linux. All your servers, Linux. Obviously you got Windows servers that are running Azure and whatnot. But a lot of the Azure servers are running Linux. That's why they incorporated the Linux subsystem on Windows now and whatnot. So the world's slowly turning into Linux dominant. Linux is great. I love it. All right. Let's continue to get back on topic here. All right. So typical Soho LAN. To begin, first thing about a small office Soho. So we got a little, again, just like we talked about. You got your little network over here, a couple, you know, you got your router, your switch, couple PCs. It's all connected, and they all, for the most part, are probably all on one subnet. All right. So this little topology right here, they're probably all 192.168.0.105. That's probably the PC1. That's probably PC1. The router is probably 192.168.0.1. All right. You know, in your house, in your own house, this is probably your router. And then, you know, if you look at your iPhone is probably 192.168.0. something. That's a typical Soho network, all right? And this is all because these are private addressing. That's not going to be covered here today, but we're going to cover that in other chapters later on too as well. So that's a typical Soho network. Yeah, go ahead, man. Ask as many questions as you want. That's what I'm here for. All right. The rap song which says mask on, mask off. Got to give you some more context, man. Was there a song playing on here that was talking about that? Mask on, mask off. I have to understand this. Mask on, mask off. I don't know. No idea. Maybe he changes his faces. No idea, my friend. How's this? I'm not a big music type guy. You know, you'll if you ever hear my channels, it's, you know, a lot of my stuff I listen to like lo-fi type music, man, just real mellow type stuff. Not too big into rap music or whatnot. You know, it's all great. I love music, no matter what it, you know, no matter the flavor. But I'm not too familiar with that one. All right. So, yep, continuing on. The IEEE. Most wireless LANs rely yet on network devices. Access points AP, very important. All right. They act somewhat as an Ethernet switch. So, you got it, man. Go check it out. So yeah, so an access point. So your home router most likely has an access point. Your home router is your access point. All right. But in say like a business that you know, is, you know, maybe you have a pretty sizely office. You know what I'm saying? That Wi-Fi router, it's not probably going to be strong enough to send that Wi-Fi signal all the way down to the offices, you know, that Bob and Larry are over here. So what you need to install is a wireless access point, all right? And what that's going to do is that's going to relay that information coming from your router. And I mean, we're going to get into Wi-Fi and everything later on. That's a whole other bag of topics. But the access point is acting like a switch, all right? It's not acting as an actual, I am making a hot mess on here. And it's not acting like a router, all right? It's not giving out IP addresses or nothing like that, all right? It's simply acting as a switch. And if we'll get into how switches and stuff like that work. But your router is still handling everything when it deals with layer 3, so network, IP. Switches deal with layer 2, MAC addresses, all right? Same thing with this, all right? The access point is dealing with, it's just relaying that Wi-Fi signal out. That's it. All right. typical enterprise network. So this is what we'll get into one of the key topics here. Enterprise networks have similar needs compared to SOHO networks, but on a much larger scale. All right. For example, enterprise Ethernet LANs begin with the LAN switch. Switches installed in a wiring closet behind a locked door on each floor in each building. The electrician installs the Ethernet cables. All right. From the wiring closet to the cubicle, so where everybody's at, all the different, the printers, the computers, and so on and so forth. The conference rooms, where devices might be needed to connect to the local area network. At the same time, most enterprises also support wireless, so everything's from your phones to your laptops. Deltron 3030. Man, I can't just I don't want to get in trouble and play music because of the whole Twitch getting in trouble. So that's why I'm using Twitch's little sound lab over here for our music that we're playing right here. This right here prevents me from getting in trouble by Twitch right now, so it doesn't allow me to just look up music on here. Like, obviously I got a Spotify account, but I can't do it anymore. I'll get in trouble. So let's continue on. All right. So again, at the same time, most enterprises also support wireless LANs in the same space to allow people to roam as they work to support the growing number of devices. That do not have Ethernet, can't plug an actual cable into them. All right. Figure 2.3 shows the conceptual view of a typical enterprise LAN in a 3-story building. Each floor has an Ethernet LAN switch and wireless LAN access points. All right. To allow communication between floors, each floor switch connects to a centralized distributing switch. For each PC, for example, PC3 can send data to PC2, but it thank you. PC2, but it would first flow through PC3, switch 3, to the first floor to the distributing switch and then back up. All right. So to kind of go over the logic, all right. So PC3, let me get a different color. All right. Make this a little bit smaller. All right. So PC3 sends a message. It's gonna go through switch 3. All right. And say it wants to get to switch 1 over there. It has to still send that packet through the distributing switch. All right. Before it can get over to PC1, all right, and we'll mock up a lab in CML, and we'll look at the packets and how the packets information we'll capture the packets within this network, so we can see specifically, another word that my speech impediment can't really say, how the packets get to where they need to be, and the information on how the information travels. All right. Looking at the packet capture is very, very useful to understanding how these devices really work. All right. So we'll continue on. All right. The variety of Ethernet physical layer. All right. The standards. This goes over the standards of the Ethernet physical links. Okay, the physical links. This again, it goes back to the actual the sizes of the information. Grab some coffee. Yum, yum, yum. I'm gonna have to make more. It's getting cold. All right. So we'll continue on. All right, here we get into this is another key topic. Now, this has been very hard for me to really nail down, but this is right here what we were discussing earlier when I was talking about how the cabling is standardized. And again, this is all the IEEE's actual standards. Okay, so the formal IEEE standard. So you have 802.3. That standard is for 10 megabytes per second Ethernet. Okay, 10 base T. All right, 802.3U. That standard covers 100 megabytes per second, 100 base T. All right, 802.3Z. All right, this is getting into fiber optics. All right, here's another key topic. All right, this is covering gigabit Ethernet. All right, 1000 base T. Well, this is 1000 base LX because that's identifying. This is identifying fiber optic. Okay, so here's the copper version, base T again. All right, so base T. All right, we got to remember these standards. These are hard to nail down because these are awkward numbers to really get in your head. But it's something, it's something to really think about. So we'll continue on. All right. Note, fiber optic cable contains long, thin strands of fiberglass. All right. That attaches to Ethernet nodes, send light over that glass fiber in the cable, encoding the bits as they change in the light. Neat stuff. Okay. Constant behavior over the link using Ethernet data link layer. Ooh, excuse me. All right. So figure 2.4 shows an example of the process. In this case, PC1 sends an Ethernet frame to PC3. The frame travels over a UDP link to the Ethernet switch 1. All right. Then over the fiber link to Ethernet switch 2. And to switch 3, finally over to the UDP link to switch 3. All right. Note that the bits actually travel at 4 different speeds. All right. It's the same information, but it's traveling through different actual cabling. So you have 10, 1000. All right. It doesn't go through here. It's going to go through this switch now. All right. But then it hits this and it's going to 10. All right. And it's going to come down here. It's going to go through 100. Again, this is just high level, talking about the physical. This is all about the physical cabling. That's what this chapter is covering. All right, so we don't have to get too crazy into that. It's very important though that we think about this stuff. All right, build in physical Ethernet LANs with UDP. This next section covers of this chapter focuses on individual physical links between any two Ethernet nodes, specifically those that the unshielded twisted pair. There we go. Key terminology. UDP, unshielded twisted pair. All right, UDP, unshielded twisted pair. All right, key topic. All right. Before the Ethernet network as a whole can send Ethernet frames between users' devices, each node must be ready and able to send data over the individual physical link. All right. This section focuses on 3 most commonly used Ethernet standards: 10 base T, 100 base T, and 1000 base T. All right. Ethernet, fast Ethernet, and gigabit Ethernet. All right. And you're gonna see this when we start using network devices. You're gonna see this terminology. All right. Gigabit, fast, and Ethernet. All right. Because the actual ports on the devices could be a Ethernet port, a fast Ethernet port, or a gigabit Ethernet port. All right, because the ports themselves, once we get into the devices, all right, they have certain speeds too as well. And then when you're dealing with switches, switch logic, you could, by messing up the actual speeds on certain ports, you could actually start messing up how the information is being processed as well. And you can actually reduce the speed of the information by reducing the speed of the port. But that's, I believe that gets to chapter 3 when we start talking about layer 2 switches. All right. All right. Transmitting data using twisted pair. All right. While it's true that Ethernet sends data over UDP cables, the physical means to send the data uses electricity that flows over the wire inside of the UDP cable. To better understand how Ethernet sends data using electricity, break the idea down into 2 parts: how to create electrical current, and then how to make the electrical signal communicate. Ones and zeros, bits, the bits. Binary. I probably spelled binary wrong, all right? 1110011001101. All right. At the end of the day, everybody, that's all it's sending is bits, on and off, on and off. That's all it understands is on and off. All right. We're the ones that make it crazy with everything else. All right. So first, to create one electrical current circuit, Ethernet defines how to use the 2 wires inside of the single twisted pair of wires. As shown in figure 2.5, the figure does not show how UDP cable between 2 nodes, but instead shows the 2 individual wires that are inside the UDP cable. An electrical current requires a complete loop. So the 2 nodes using circuitry on the Ethernet ports connect the wires in one pair to complete a loop, allowing electrical current. All right. So that's just a simple, this is how it works. All right. That's how the physical cable is sending the information. All right. All right. It needs to complete an electrical circuit. All right. I'm going to continue on breaking down a UDP Ethernet link. The term Ethernet link refers to any physical cable between 2 Ethernet nodes. To learn about how the UDP Ethernet link works, it helps to break down the physical link into those basic pieces. As shown in figure 2.6, the cable itself, the connectors on each end of the cable, and the matching ports of the devices in which the connector will be inserted. RJ45. Connect. Boom! I got my network. All right. Gonna continue on. Nope. If available, find a nearby Ethernet UDP cable and examine the connectors closely. Look at the pins for the colors, for the pin positions and the colors. I believe. Hold on. I got a whole bunch of actual cabling. Where's it all? I did have like a whole box full of random Ethernet cabling, but over here it shows a good it's actually really good pictures. So here's your Ethernet link, NIC. All right, your network. All right, this is inside of your computer. All right. Well, if you can plug an RJ45 cable into it, this is what it's connecting into. All right, that's what's in here. This is the actual cabling, the RJ45. All right. All right. Let's continue on here. This is going to go into so 10 gigabit SPF with cabling sitting just outside the catalyst. So this is just the actual Cisco switch, the catalyst 3566. Woo! That's a beautiful switch. All right. We'll continue on. So you got small form factor, SFP, small form factor, pluggable plus. Well, that's just going over some of the terminology. UDP cabling pinouts for 10 base T and 100 base T, okay? This is where, this is a area right here that I have to start actually physically manipulating these cables So just to get more hands-on for myself, to just dig into my memory, straight through cabling and crossover cabling. So that's what this is going to touch on right here. All right. So 10 base T and 100 base T uses 2 pairs of wires in the UDP cable, one for each direction, as shown in Figure 2.9. The figure shows 4 wires, all in which sit inside the UDP cable that connect a PC to a LAN, local area network switch. In this example, the PC on the left transmits using the top pair. All right, top pair. All right, and the switch on the right transmits using the bottom pair. All right, data flowing. Woo! Transmitting, receiving. Transmitting, receiving. All right. Figure 2.9. Using 1 pair for each transmission direction with 10 and 100 megabits per second Ethernet. For correct transmission over the link, the wires in the UDP cable must connect to the correct pin position in the RJ45 connection. For example, in 2.9, the transmitter on the PC on the left must know the pin position on the 2 wires it should use to transmit. Those 2 wires must connect to the correct pin on the RJ45 connector on the switch, so that the switch receiver logic can use the correct wires. All right. So that's why. So it's important to understand that, because if you're using network devices, there's a actual on some of them there's a console port. All right. And this was a great example that another great author that I follow as well. His name is David Bombal. He on one of his descriptions, he really stressed the fact when you're dealing with cabling, you have to understand cabling is just as important as understanding the actual network devices. Okay, because you can start blowing actual NICs, the actual receivers, by plugging in the actual wrong type of cabling into those devices. All right, because you'll see, take your standard Ethernet cable. It all looks the same. It has a RJ45 connector on it. If you don't know what you're looking at, you don't know if you have a crossover or a straight through or a console cable. You plug it into the wrong port, you can then blow that port, all right? Or that port just won't work. It won't understand that information, okay? Because again, at the end of the day, it's sending bits, all right? Which is information, all right? If you're sending the wrong information, it's not going to know what it can't understand that logic, all right, behind it. If you're using the incorrect cabling for those devices, for those NICs, okay? All right, NIC, all right. All right, to understand the wiring of cable, which wires need to be in which pin position on both ends of the cable, you need to first understand how the NIC and the switches work. As a rule, Ethernet NIC transmitter uses the pair connector to pin 1 and 2. The NIC receiver uses the pair of wires at position 3 and 6. So, do they give a better? I think they give a better. Okay. All right. So it gives a good. Where was I though? Yeah, we'll come right here. I'll grab my handy dandy highlighter right here. All right. So that. Whoa. Too small. All right. So this right here, this is what it's describing right here. So this is an actual RJ45 connector. Okay, it's pretty much like sliced it in half, and this is what it's covering with the actual connectors. Okay, and once you get into like, if you're responsible for cabling and stuff like that, you could be the one that's cutting these cables, hooking up the RJ45 connectors on these cables. You got to know which ports they're connected to before you crimp them. Okay, if you just wandy nandy, just doing whatever, you're not going to be positioning these cables in the right spot. You're going to be blowing nicks left and right, or your network devices just ain't going to work. All right. All right. To allow the PC NIC to communicate with the switch, the UDP cable must also use straight through cabling. I want my mouse. All right. Straight through cabling pinout. All right. The term pinout refers to the wiring on which color the wire is placed in each of the 8 numbered pin positions in the RJ45 connector. A Ethernet straight through cable connects to the wire at pin 1 on one end in the cable to pin 1. 1 and 1. 1 and 1. Straight through. All right. On the other cable, the wire in pin 2 needs to connect to pin 2, pin 2, and pin 2. All right. And then on the other end, pin 3 connects to pin 3, and so on and so forth. All right. And then it comes down here. Show the final in figure 211 shows the final perspective of the straight through cabling. Cabling through pinout. In this case, PC Larry connects to the LAN switch. Note that the figure again does not show the UDP cabling, but instead shows the wires that sit inside of the cable to emphasize the idea of the cables in pinouts. All right. So he's transmitting on pin 1 and 2. He's transmitting on pin 1 and 2, but he's receiving. All right. Very important. Goes back to the logic on how this stuff works. All right. This is the low level of how these network devices work, guys. All right. So again, you got Mr. Larry over here. All right, and then you got Mr. Switch over here. Here's pin 1, pin 2, pin 3, and then pin 6. And then over here, pin 1, pin 2, pin 3, pin 6. Okay? He's transmitting on these 2 bits. So on the switch, he needs to receive on those 2 bits. So here we go. There's a connection right here on those 2 pins. Same thing for 3 and 6. He's receiving on 3 and 6. So on the switch, he's transmitting on 3 and 6. All right. So there's pretty much the logic on how that works. All right. Remember, guys, this is low level, but this is fundamental. All right, now we're going to get into, I believe, crossover. But let's finish up with straight through cabling. Straight through cable works correctly when the nodes use opposite positions for transmitting data. However, when two like devices connect to an Ethernet link, they both transmit on the same pin. All right. All right. So now this is getting into the realm of because of how they switch logic. So switch logic is different than PC logic. All right. PC logic is similar to how router logic is. Okay. So when you think logically, a PC and a router use the same similar logic, where a switch is a bridge logic, hub logic. All right, that's the logic, or AP access point. They're using the similar type of logic. Okay. All right. Woo! I made a mess out of my whiteboard. Wonder why I go through so many dryer. I got a whole box full of black dry erase markers. I guess for a reason. So, continue on. All right. While the previous sentence is true, the concept is much clearer when the figure, such as figure 212, the figure shows, now let's go take a look at that. The figure shows what happens on the links between the two circuits. The two switches both transmit on the pair at pin 3 and 6, and they both receive on pin 1 and pin 2. Again, we'll go back to logic. And this is, what are they using? They're using they're using two switches in this. So we have Mr. Switch over there, Mr. Switch. So switch 1, switch 2. Remember, so pin 1, no, what are they receiving? Yeah. So this is, yeah, so they're receiving, remember, so they're receiving and then transmitting. So pin 1, pin 2, pin 3, pin 6, receiving, transmitting. So in this logic right here, you're going to have, it's not going to be able to it's not going to be able to successfully understand what's going on. That's when the crossover cabling comes into play, and this is what it's getting at right here. And that's why, as you can see from this demonstration, what's going to happen is pin 1 is going to connect to pin 3. All right, pin 2 is connecting to pin 6. Pin 1 to pin 3, pin 2 to pin 6. Okay, that's how then it's successfully able to receive. Again, because it can only receive on pin 1 and pin 2. All right, and it can only transmit on pin 3 and pin 6. That's why we have to cross over the cables again. So the logic is still sound on how the switch can understand. You know, the switch ain't gonna just change its logic. So we have to make sure we're using the correct cabling for that. All right, let's continue on. Choosing the right cable pinup. For the exam, you should be well prepared to choose what type of cable, straight through or crossover. It is needed in each part of the network. The key is to know whether the device acts like a PC, all right, if it has a NIC, all right, transmitting on pins 1 and pins 2, or like a switch that's transmitting on pin 3 and pin 6. So we'll clarify again, the reason why I am really hammering this, honestly, it's for myself, all right, to understand the logic, all right. So PC logic again. So PC logic, switch logic, all right. PC logic says it is on pin 1 and pin 2. Switch logic, pin 3 and pin 6. All right. It is stating that it is transmitting. I probably spelled that wrong. Transmitting. All right. On pin 1 and pin 2 for PC logic. On switch logic, pin 3 and pin 6. All right. So if we can understand just that simple concept on how this works, we'll know that if we're connecting two PCs together, all right, two PCs together are going to communicate is going to transmit again on those two pins. So we're going to have to use a crossover cable so those two devices can work, all right? Same thing with a switch, all right? We have two switches. They're both transmitting on pin 3 and pin 6, all right? Again, we're going to have to use a crossover cable for those two devices. But when we connect a PC to a switch, it's straight through because they have opposite logic, all right? Since they have opposite logic, we get to use a straight through cable, all right? Now, like I said before, routers fall into the realm of PC logic. Hubs, access points fall into the realm of switch logic, okay? So as long as we continue to put that into memory on how that works, that's going to help us to understand straight through cabling and crossover cabling, all right? Now, continue on. All right, crossover cabling If the endpoints transmit on the same pair, there we go, just like we said, straight through cabling. If the endpoints transmit on the different pair. Beautiful. Awesome sauce. Ooh. I revert. I'll take one thing back. I was wrong about wireless access points. They transmit on pin 1 and pin 2. A little confused about that, but there. So there we go. So that actually, let me take that back, and we'll put access points into the realm of PC and router lab. All right. Again, there we go. So again, here we go. So straight through cabling, crossover cabling, because these two switches are talking to each other. Straight through cabling. All right. So if we were to connect though, if we were to connect these two PCs though, this would be crossover cabling. Okay. But since we're connecting these PCs to the switch, it's straight through cabling because they're transmitting on the opposite pins. All right. These two switches though, right here, they're transmitting on the same pin, so we need crossover cabling. All right. I think I've nailed that. I think I've punched that nail in that head a couple times into my memory banks. All right. Note: if you have some experience with installing LANs, you might be thinking that you have used the wrong cabling before, straight through crossover, but the cable worked. All right. Cisco switches have a feature called auto MDX that notices when the wrong cable is used and automatically changes the logic. So Cisco knows that, you know, maybe we might have some not so versed people on the pin logic, so they've built into their switches. Now this is getting to the realm of smart switches, okay? Which is, you know, when you start getting into, you know, layer 3 type switches and whatnot. Because layer 3 switches, they're pretty much routers. They can do almost everything a router can do. And we'll get into that later. However, in the exam, be ready to identify whether the correct cable is shown in the figure. So part of the exam is to know cabling. That's why we're really getting into this topic, okay? Again, it's just going through the actual pinout for the logic. All right. Now it's going to get into building Ethernet LANs with fiber optics. Okay. I don't actually have any fiber optics in where I live. I haven't even touched fiber optics, honestly. It's neat though. Obviously, it could send information. It sends information by light. But there's two types of cabling. Let me just hold on one second. Sorry, got a couple monkeys in the background being crazy. All right, so fiber cable and transmission concept. So fiber optic cabling uses glass, fiberglass. All right, as the medium through which light passes, varying the light over time to encode zeros and ones. All right, so the bits. All right, binary bits. All right, equals binary. I'm an awful speller, don't judge me. 1 0 1 0 0 0 1 1 1 0. All right, it's sending this through light. All right, through the cable. So the cable is gonna get a there's an encoder. So when your PC sends the signal, the encoder transmits that into a light. So it gives it like a certain light, a spectrum of light, and that's that's how the encoder on this. So well, there's an encoder that transmitted into a certain spectrum. It sends that through the fiber optic cable through another encoder, which understands that spectrum of light, and then encodes that back to the PC on the other end and turns that back into 0001111 whatever. Okay, so that's how the fiber optic. All right, that's how the kind of like the fiber optic logic works. There's two types of fiber optic, and that's what it's going to get into right here. All right, instead of using instead of fiber optic cable, use a fiber guide, which allows the manufacturer to spin long, thin strands fibers of flexible glass. Fiber optic cabling holds a fiber in the middle of the cabling, allowing the light to pass through the glass, which is very important attribute for the purpose of sending data. Although sending data through the glass fiber works well, the glass fiber by itself needs some help. The glass could break. It's glass. One thing about fiber optic cabling is it can only be bent so much. All right, because when you start actually curving that actual cabling, it's actually messing with how that wavelength of light is being transmitted. All right, and then obviously you can break it because it's glass. Right? Sensitive stuff, expensive too. All right, so here it's getting into the actual outer layers. All right, outer jacket, obviously to protect it. All right, this is probably, obviously this is some kind of this is most likely some some insulated rubber. This is probably some maybe some plastic compound. This right here is I believe it's working with, so the cladding is actually reflecting, so the cladding acts as a reflector to reflect that light back into the core. All right, because you gotta think that light signals, it's not always gonna end up going straight, so that cladding is reflecting that light back to the core so that signal can still go. And the buffer probably acts again as just some more protection for the actual cabling and whatnot. All right, the three outer layers protect the inner core. So the buffer and the strathrow and the outer jacket protect the inner core, which makes the cable easier to install and manage. While the inner cladding and the core work together to create the environment to allow transmission over light, the transmission of light over the cable. A source of light called the optical transmitter shines light into the core. Light passes through the core. However, the light reflects off the cladding. Again, like I was just explaining, when it's sending the actual light signal, it's gonna go all over the place. It's not always just gonna be a straight shot line. It might be in one case, but for the most part, it's not gonna be a straight shot line. So that cladding, it's a reflective material that's allowing the light to go back to the core, so it continue on its path. All right. So figure 2.6 transmission of a multi-mode. Here we go. We're gonna get into the two separate actual fiber optic stands. So transmission on multi-mode fiber with internal reflection. All right. The figure shows the normal operation of multi-mode fiber, characterized by the fact that the cable allows for multiple angles of light waves entering the core. In contrast, you have single mode. Hold on. It's bouncing all over the place. All right. So in contrast, single mode fiber uses a smaller. So here we go. You can actually, it gives a really nice. So you have multi-mode and then single mode. So in contrast to single mode uses a smaller diameter core, allowing for a 1/5 of diameter core of the multi-mode to transmit. So by making the actual glass in the cable smaller, it's forcing that light to go into a straight shot line. So in theory, by not allowing the light so much area, you're only giving it a certain path that it can travel, instead of giving the light a bigger area, which allows that light to just bounce around all over the place. All right, let's continue on. All right, so transmission over a single mode fiber with laser transmitter. Both multi-mode and single mode cabling have important roles in the Ethernet and meet different needs. Multi-mode improves the maximum distance over UDP, and it is less expensive transmitter as compared to single mode. Standards do vary. For instance, the standard for 10 gigabit Ethernet over fiber allows for distance up to 400 meters. All right, a good distance. All right, which would often allow for connections of devices in different buildings. Okay, so this would barely be, say, like a campus, like a university. All right, you got, you got or like an Army Navy base too. Same type of campus design. You have multiple buildings that span across a whole entire area, and you wanna as a network architect, you want to ensure not only are you able to send the actual information, you're utilizing your resources to your best advantage, and that gets with cost and planning as well. And a lot of this is planning for the future and well as too. All right. So which allows for connection over different buildings, small office parks. Single mode allows distance into tens of kilometers with slightly more expensive. You get into more expensive hardware. The transmitter between two devices, you need two cables, one in each direction as shown. All right. The concept works like having two electrical circuits. So it has to do the same logic. So transmitting on one end and receiving on one end. All right, so here you go. Transmit, receive, transmit, receive. We're gonna get back into that same type of logic. All right, but again, it's a continuous loop though. All right, even though we're dealing now with light, that light still has to use the same logic as an electrical circuit. All right. Using fiber with Ethernet. To use fiber with Ethernet switches, you need to use a switch with either a built-in port that supports the partial optical Ethernet standard. So you're gonna have to have an actual a different port. You're not just gonna be able to use an RJ45. That's not how it works. You need a specialized module or port that allows the change from Ethernet standard. Using the port referred to figure.8 that shows a photo of a switch that has two SFFP ports into the insert. Yep, and so let's go back up here, and here's the IEEE. Here's the IEEE standard. Okay, 802.3. All right. Here's some of the max distances with the cabling types right here. All right. These are key topics right here, guys. So these are the standards without a repeater. Okay, so this is just straight shot without a repeater. You add a repeater to this, obviously you're going to be able to increase your distances, whatnot. Just like an electrical circuit. Okay. For instance, to build an Ethernet LAN in office park, you might need to use some multi-mode and some single mode fiber links. In fact, many office parks might already have fiber cable installed, to expect, again, here we go, that same terminology, to expect future use by tenants. So as a network architect, a lot of the stuff is you gotta think forethought, you gotta think ahead, and that's a lot of this is planning ahead for what it's gonna be, because everything's expanding. And then as a network architect, you gotta have that kind of mindset of, you know, what's gonna be next. Okay, even though it's not right in front of you, but you gotta think, plan ahead. All right, because if you plan ahead, you save money. You don't plan ahead, you spend more money. All right. Let's read the note. Outside the need of to study the CCNA, if you need to look more deeply at the fiber Ethernet in SFP and SFP Plus, check the. So here's an actual link right here, the TMX matrix in Cisco. So if you guys want to check that out, there you go. There's that link right there. If you're interested in checking out some more of the standards, all right. Although the distance might be the first criteria for considering and thinking about using UDP over fiber. So again, thinking about that. All right. Let's continue on a little bit, guys. So this is just going over some of the criteria: relative cost of cabling, relative cost of switch port, approximate distances, relative susceptible to the interface, relative risk of copying from cabling for cable emission. Okay. Sending data in the network. All right. Now, this is getting into the actual some of the actual transmitting that's going through this cabling. All right. So what do we got? So one of the most significant strengths of the Ethernet family protocol in these protocols is use the same data link standard. In fact, the core parts of the data link standard date back to the original Ethernet standard. So it all goes back to the same Ethernet standard. All right. It's all, even though we've advanced in the speed in which we can send this information through this cabling, it still goes back to that same standard. Even though, again, we're sending bits through light now, we're sending bits super duper fast now, it's still the same logic. No matter what, it's still the same logic. All right. This is just showing a common Ethernet frame here. So we're gonna get into that: preamble, SFP, destination, source, type, data and pad and FSC, header and trailer. All right. This is getting into data encapsulation. Again, how when we were talking yesterday on the TCP, all right, model, the 5-layer model. All right. You know, you have your app. You have, you know, what we're gonna say, you know, your SSH protocols, your HTTPS protocols. All right, that's at the very top layer, the 5th layer, but that's gonna send data down to the TCP, UDP. All right, UDP transmission protocol. Okay, so that's gonna send that down to the IP network level. All right, so this is just the data being encapsulated, then down to the layer 2, which is MAC address, MAC addressing, and frames. All right, and then finally, again, all this data is being man, that's a tough word. My speech impediment's awful. I thought I got rid of it years ago. It still haunts me. Incapacitable. All right, so then you get down to the very last layer. So this is where the bits are. All right, this is the cabling. And then once it gets down here, and then it sends it through the wire to whatever PC up here, and then obviously then that the data is then being so it's being uncapsulated. Man, I'm gonna have to sit in the mirror for a couple of days and go over that word. All right, and then the data is being obviously transmitted back up the TCP ladder again. So then obviously you can get to your HTTP, your SSH level, and then you can, your web browser and whatnot, so you can get your web page and whatnot. All right, so that's this is the start of how that data is being crunched up and transmitted through the actual bits here. All right. So while the fields in the frame matter, some matter more to the topic discussed in the book. Table 2.6 lists the fields in the header and trailer in a brief description for reference, which upcoming pages include more detail about these few fields, okay? So preamble, SFD, start frame delimiter, destination MAC address, source MAC address, type, data, and pad. So when we're gonna capture some packets, all right, this is where you're gonna start seeing what this data is, all right, when you start capturing packets, all right. The IEEE 802.3 specification limits the data portion of the 802.3 frame to a minimum of 46 and a maximum of 1500 bits. Man, I'm Joey Mumbles right now. Huh. The term maximum transmission unit, MTU, defines the maximum layer 3 packet. So packet layer 3, all right, IP, all right, a layer 3 PDU, all right, layer 3, all right, that's on the IP, all right, the network layer, all right. Let's just drill that into our heads a little bit. The rest of the data portion in the Ethernet frame, the 1500 bits is the largest IP maximum transmission unit allowed over the Ethernet frame. So it's a big chunk of data. All right. Ethernet addressing. The source and destination Ethernet address fields plays a huge role in how the Ethernet local area networks work. The general idea for each is relatively simple. The sending node puts its own address in the source address field, and the intended Ethernet destination device address it in the destination address field. The sender transmits the frames, expecting the Ethernet LAN as a whole will deliver the frame to that correct address. Okay. Again, this goes back to addressing, but this is talking layer 2 MAC addressing, MAC address, okay? That's switch logic, okay? Ethernet address is also called media access control. Let's write that down. All right, MAC. My boy, you remember Mac and Me? You remember Mac and Me? I remember Mac and Me. Boy, that was an ugly alien, but I loved that movie growing up. Mac and Me. Media, access, control. All right, MAC address. All right, not Mac and Me. Man, let me see if I can draw that alien. I still remember what he kind of looked like. He had some funky ears, and his eyes were really close. And then his mouth. All of them had a circle mouth, if I can remember, and they had little fat bodies. Mac and Me. They all looked alike too. And what was it? They got sucked into like some. They all got sucked into a satellite or something like that. The whole entire family. All right. We're getting off topic now. Most MAC addresses represent a single NIC or an Ethernet port. So your NIC in your computer, in your router, they have a MAC address assigned to them, okay? So these addresses are often called a unicast Ethernet address. They were ugly. They were awfully ugly, but he was so cute. All I remember is the mouth. The mouth was the worst part about them. They were all of them. They just had they were all mouth breathers. The entire idea of sending data to a transmission unicast MAC address works well, but it works only if the unicast MAC address are unique. So you can't have two same MAC addresses. It won't work. Just like you can't have two same IP addresses. It just won't work. All right. If two NICs try to use the same MAC address, it could obviously be confusing. The problem would be like confusing, obviously having the two same addresses. If a postal service has, got a letter, well, I guess they would just send it to one. But the house, if you had the same address as Tom down the street, you might get Tom's mail or Tom might get your mail. Ethernet solves this problem by using an administrative process so that at the time of manufacture, all Ethernet devices are assigned a universal unique MAC address. Universally unique MAC address. Before the manufacturer could build an Ethernet product, it must ask the IEEE. Again, the IEEE sets the standard on all. I'm going to tell you, it sets the standard on most of all this stuff, okay? Even though they deal with electricity, all this stuff is still electricity. It's all still sending bits, all right? So it must ask the IEEE as a standard. So, and the IEEE it's gonna assign a manufacturer a unique universal identifier. Unique universal identifier, all right? UNIQUE, that's my daughter's name. Universal, yeah, sure. Universal, my spelling's awful. Identifier. All right. The IEEE assigns that to the manufacturer. All right. It assigns. Look at that, MAC for manufacturer. It assigns a unique identifier so that they can universally. You'll have different MAC addresses, all right? And this is where it gets into where the actual bits are assigned. Before, yep. And the unique, the universal unique 3-bit code called the organization unique identifier. There's another key term, all right? That terminology came up on our. That terminology itself, the OUI, they came up on our questions in the beginning. And here we go. So that's the organizational unique identifier. All right, OUI, organizational unique identifier. The IEEE assigns a 3-bit code to each manufacturer. All right. The manufacturer agrees to give all NICs and other Ethernet products a MAC address that begins with its assigned 3-bit OUI. The manufacturer also assigns a unique value to the last 3 bits. So the IEEE, so the OUI. First 3 bits, so the first 3. And then the manufacturer down here. All right, so the IEEE gives it the first, the manufacturer, the last 3 bits. All right. All right. It's going to assign, it's going to assign the last 3 bits a number that the manufacturer has never used with the OUI. As a result, the MAC address of every device is universally unique. So that's how we're getting these unique numbers, okay? All right, let's move on. So the IEEE also calls the universal MAC address addressing global MAC addressing. All right, just kind of nails that on the head. And here's a great picture, well, a great example of how this is work. So the OUI, Organizational Unique Identifier, all right? And then the vendor assigned. So there we go. So there's a great example of how you're gonna get that universally unique identifier, all right? The structure of the unicast Ethernet addressing. Ethernet addressing goes by the lane by many names: LAN addressing, Ethernet addressing, hardware addressing. Burned in, there's another one you're gonna hear a lot: burned in addressing, physical address, universal address, or MAC address. So when you hear MAC, Mr. Mac and me, think burned in, all right? Burned in address, all right? Not IP, not IP, all right? IP is not given by the manufacturer. That's totally different than MAC address, okay? Your NIC, your actual where you plug that cable in, your phone, all right, your phone itself, your phone has a wireless NIC in it, and inside of that, your phone has a unique MAC address, okay? Your laptop, even though you don't actually hook a cable up to that, you know, if it's connected via Wi-Fi, there is still a unique universal identifying MAC address in that, okay? From the manufacturer, okay? You know, Mac, again, Mac, Mr. Mac and me is layer 2, okay? Layer 2 PDU, all right? And then IP is the next stage up. We haven't got into that yet, and this is, again, this is layer 3, all right? Layer 3 PDU, all right? Network, IP, frame, MAC. So when you think IP, you think network. When you think MAC, you got to think frame. All right. Let's continue on. Broadcast addressing. Frame sent to this address should be delivered to all devices in the Ethernet LAN. So here we go. So here's a simple FFFF address. So it's just gonna pretty much just get blasted out to everybody. Broadcast, everybody. Multicast address. Frame sent to a multicast Ethernet address and will be copied and forwarded to a subnet of devices on the LAN. The voluntary to receive the frame sent to the specific multicast address. Okay. So here we go. So here's some really good key topics to kind of settle on. MAC, media access control. All right. 802.3. Define the MAC address sublayer by the IEEE. All right, Ethernet addressing, NIC address, and LAN. Other names that are often used for the MAC address. All right. Here we go. Burned in address again. The 6-bit assigned by the vendor. All right. Unicast addressing. A term for MAC address that represents a single LAN interface. Broadcast address, an address that means all devices that reside on that LAN right now. All right. So, I know we haven't touched on this yet, but when we get into subnetting, all right, when we get into subnetting, subnetting is going to be a really deep topic. I mean, that might take me a day or two to actually cover. But you can have separate broadcast addresses in each subnet, okay? And that's usually identified when you'll see an address of 255. So you'll see 192.168.1 with a 255 ending in it, covering that broadcast, that subnet's broadcast. Same thing over here. You'll have 192.168.2.255, all right? So that's covering a separate subnet, but that's the broadcast for that subnet right there, all right? And then multicast, an Ethernet multicast address implies some subnet of all devices currently on an Ethernet LAN, all right? Identifying network layer protocols with the Ethernet type field. While Ethernet headers address plays an important role and more obverse role in the Ethernet LAN. The Ethernet type fields plays a much less obvious role. The Ethernet type fields and Ethernet type sits in the Ethernet data link layer header, but its purpose is to directly help, the network processing on the router and host. Basically, the type field identifying the type of network, all right, the layer 3 packet. So now it's gone up to IP, to network, okay? That's why it mentions routers and hosts. Routers and hosts deal with IP, all right? Switches deal, layer 2 switches deal with Ethernet MAC addresses, okay? All right, that's when you're gonna get into ARP tables and whatnot, all right? First thinking about what sits inside of the data part of the Ethernet frame shown earlier in 2.14. All right, this is a great, this is a nice little breakdown on that terminology. All right, really good. All right, I might print that up, put it on my wall. All right, so here we go. For the example, a host can send an Ethernet frame with an IP4 packet in the next Ethernet frame with the IP version 6. So now it's touching on some IP4 and IP6 packets. Each frame would have a different Ethernet type field value using values reserved by the IEEE. All right. So it's now we're getting into the actual packets and whatnot. Let's continue on. Error detection with FCS. All right, Ethernet also defines a way for nodes to find out whether a frame bit changed while crossing over an Ethernet link. Usually the bits would change because some kind of electrical interference or bad NIC. All right, so this is touching on, we're gonna get into collisions and error detection and how we had to build certain algorithms inside of these devices to detect that and then to compensate for that. Because there's really, to prevent it, obviously to prevent it, you make sure your NIC is good, your cabling's good. That goes into troubleshooting your network and whatnot. All right. So Ethernet also defines a way for nodes to find out whether a frame bit is changed while crossing over the Ethernet frame. Ethernet, like most data link protocol, uses a field in the data link trailer for purposes of error detection. The Ethernet frame, so here, FCS, another term to remember, frame check sequence. FCS, frame check sequence, okay? Whatever, I can't spell. Okay. All right. In the Ethernet trailer, the only field in the Ethernet trailer gives the receiving node a way to compare results with the sender to discover whether errors occurred in the frame. The sender applies a complex math formula. That's where the algorithm comes in to the frame before sending it. Storing the results in the formula in the FCS field, the receiver applies the same math formula to the receiving frame. The receiver then compares it to its own results with the sender's results. So it's what it's doing, it is sending the FCS field, okay? So it is sending, the receiver is sending this formula, this algorithm over to the receiver. So we have the transmitter over here sending the FCS, the receiver is receiving the FCS. When the other packet comes in next, the receiver then compares the FCS to the transmitter, and then if they match, it obviously knows that there wasn't anything. But if it doesn't match, that's when the algorithm comes in place, and then it requests another frame, obviously. So let's continue on. Note, the error detection does not also mean error recovery. All right. Ethernet defines the error frame should be disregarded. So it's just going to toss that out. But the Ethernet does not attempt to recover the lost frame. Or protocols, notably TCP, all right, recover the lost data by noticing that the loss of the sending data again. All right. PC1, sending Ethernet frames with switch and hubs. Ethernet LANs behave slightly different depending on whether the LAN, the local area network, has mostly modern devices. In particular, local area network switches instead of some older local area network devices called LAN hubs. Basically use the modern switch that allows formulas for full duplex logic. Okay, remember, now we're going to get into duplex logic. Okay, which means faster and simpler than half duplex. Okay, you can actually, when we get into layer 2 configurations, we're going to mess with some of those settings to set half duplex or full duplex logic depending on the device itself, which is required when using hubs. Okay. The final topic in this chapter looks at these basic differences. Sending in modern Ethernet LANs using full duplex. Modern Ethernet LANs use a variety of Ethernet physical standards, but with the standards Ethernet frames that can flow over these types of physical links, the individual link can run at different speeds. So we're going to be able to vary those speeds. But each link that allows the attached nodes to send those bits in the frame to the next node, they must work together to deliver the data from the sending Ethernet node to the destination. The process is relatively simple on purpose. The simplicity lets each device send a large number of frames per second. Figure 2.22 shows an example in which PC1 sends an Ethernet frame to PC2. Okay, so here's its simple logic right here. PC1 is going to send this frame over to switch 1. Switch 1 is going to send it over to switch 2. And switch 2 is going to send it over to PC2, which receives it and compares it. All right. An example of sending a modern Ethernet LAN. PC1 sends the original Ethernet frame using its own MAC address as the source address, and PC2's MAC address allows the address as the destination. PC1 is sending it to the PC2's MAC address. Switch 1 receives the forwarding frame. The Ethernet frame goes out of gigabit Ethernet 0-1, all right? Short for gigabit Ethernet on switch 2. Yep. Switch 2 receives the forwarding frame out of fast Ethernet. So fast Ethernet 0-2. Short for fast, yep. PC2. PC2 receives the frame, recognizing the destination MAC address as its own, and processes the data. So PC2 gets it. It says, okay, this is it's the destination on this packet is my MAC address. So it must be mine. All right. If it wasn't, so in this typical network, if there was more devices, if PC1 was to send out that same frame in this type of environment, all the other devices would actually get this same packet as well. Okay, it's gonna, and if you use Cisco Packet Tracer, you can actually see how those packets would be broadcasted out to all the other devices. Okay, because layer 2 logic is not smart logic. Okay, and all these devices would get that same frame, but depending if it had that destination MAC address, whatever NIC had that same relating MAC address would then process that information. Okay. Key topic: half duplex. The device must wait to send its current receiving frame. In other words, it cannot send and receive at the same time. Full duplex, the device does not have to wait before sending it. It could send and receive at the same time. So half duplex, send, I gotta wait, then receive. Okay, half duplex, send, I gotta wait, then receive. Okay, full duplex, sending and sending and receiving, all at the same time. All right. So with all PCs in the LAN switch, a LAN hub, and no LAN's hub, all the nodes can use full duplex. All nodes can send and receive on their ports at the same time, same instance in time. For example, in Figure.2, PC2 and PC1 and PC2 could send frames to each other simultaneously, so they could send it at the same time. All right, in both directions without any half duplex restrictions. Okay, using half duplex in a LAN with LAN hubs. To understand the need for half duplex logics in some case, you have to understand a little bit about older network devices called LAN hubs. When the IEEE introduced the 10.base-T in 1990, Ethernet switches didn't exist. So switches didn't exist. There were hubs, then bridges, and then bridges turned into switches. Okay. Instead, network devices called LAN hubs, like a switch, a LAN hub provided a number of RJ45 ports as a place to connect links to a PC. However, hubs use different rules for forwarding data. LAN hubs forward data using physical layer standard rather than data link standards, are therefore considered to be a layer 1 device. So layer 1. So that's at the physical layer 1. Layer 1. That's the physical layer. All right. That's dealing with the 1 0 0 1 0. So that's dealing with the actual bits. All right. So that's as dumb as the logic is gonna get. So if you can imagine, as you climb up the ladder on the TCP or OSI model, the logic, things are starting to get smarter. All right. You can almost think about it in that kind of aspect as well. All right. The downward side of using LAN hubs is that two devices transmit a signal at the same instance. The electrical signal collides and becomes garbled. So that's where the collision comes in. All right. The hub repeats all the receiving electrical signals and even receives multiple signals at the same time. Figured out 2.23 shows the idea, which PC1 Archie and Bob sending an electrical signal at the same time, in the same instance of time, and the hub repeats, repeating both electrical signals out towards Larry. All right. Let's read the note real quick. For completing this, note that the hub floods each frame out of all ports except the incoming ports. So Archie's frames goes to both Larry and Bob's. Bob's frame goes to Larry and Archie. So again, it's just flooding out. It's just flooding these frames out to everybody. All right. And again, it's causing a lot of collision. Hubs, garbage. That's why hubs are slowly phasing their way out. Right. Yep. So we'll go over this key topic real quick. Figure 2.24 shows an example with full duplex links on the left and a single hub on the right. The hub then requires switch 1. So on this switch, even though this switch's port, the fast Ethernet 0.2, can run at full duplex, you have to configure it at half duplex to compensate for this hub's logic right here. Okay. All right. But again, if you're on modern devices, on modern even layer 2 switches, you don't have to worry about half duplex and full duplex. It's only if you're dealing with hubs that you have to compensate for that hub logic. Again, this goes back to logic. All right. All right, we're at the chapter review part. Man, this has been pretty good. So one key of doing well on the exam is performing repetitive reviews. Yep. Gonna go over using that. So some of the key topics, review of key topics. All right. So figured out 2, drawing a typical wire and wireless enterprise LANs, several types of Ethernet LANs, and some details about conceptual drawing. So it's just covering some of the key topics. So here's some key terms that we should know: Ethernet, IEEE, wired LAN, wireless LAN, Ethernet frame, 10 base T, 100 base T, 1000 base T, fast Ethernet, gigabit Ethernet, Ethernet link, RJ45, Ethernet port, network interface card, NIC, network interface card. All right, straight through cable, crossover cable, Ethernet addressing, MAC addressing, unicast addressing, broadcast address, frame check sequence, FCS, frame check sequence, transceiver, multi-mode, single mode, electronic magnetic interface. Right, we really didn't cover that. Core cladding, obviously for fiber optic and whatnot. So we've covered all of chapter 2. This was a pretty good review we did here. All right. And come over here. Let's go here. We're going to name this chapter 2 now. All right. And what we're going to do is I'm going to break this link. Yep. Separate Larry and Bob. And I'm going to add. What am I going to add? I guess I just add a. I'm going to add a. Even though this is technically a layer 3 switch, I can still use it as a layer 2 switch. So I could still use it to demonstrate what I want to demonstrate. So let's fire him on. He's going to take a little bit to turn on. We'll get these PCs turned on real quick. While these are booting up real quick, guys, I'm gonna go grab some water real quick. Need to grab the fridge. Hold on.
You put your camera back up?
Huh?
You put your camera right back up there?
Mm-hmm.
Was it hard?
Oh.
Oh,
Oh,
yeah.
come on.
Oh, yeah.
Guys, finish this up, alright?
Okay. Did you reset something or did you make a new one?
This is a new lab. You say hi to everybody?
Hello! How many labs can you make?
It's,
Infinite?
well, no, I can't make infinite. I can only have.
Like 50 or something?
No, I think it all depends on how much memory I gave this actual this VM, this actual computer.
Oh, so if you do like 50, it would take like 1,000 megabytes?
Depends on what images I use on it.
Oh, so like one, so like.
That's it. So as you can tell, I'm already at half capacity, and I only got like 4 labs on there. So if I make a couple more, I might be at full capacity. So I might only be able to make like 8 labs in this.
Copy? Was CPU?
CPU?
Yeah.
That's what's running the computer.
Oh.
Mm-hmm.
It has like 18.
It's at 18% usage right now, yeah. And then this is the memory, the RAM. So that's when you see memory, that you have to think RAM. Alright, and then disk, so that's
The memory card?
no, well, yeah, so that's like you know how you have like, I don't have a USB, so that's like you know how you have a USB that you stick into a computer and you can put files on it, so that's a storage device.
Oh.
So that's what you think of discs.
Also, we had some chips when we didn't finish. So you know how this week they made a new episode? I think we're on half of the episode.
Which was the other Mando?
Yep. Chapter 13. He found a Jedi.
What?
And guess what? His real name is not Yoda. I don't know, but you might have to watch it.
Alright, let me finish this up, okay, buddy? Thank you, man. Alright, let me close the door.
Can't believe when I watched it, I was surprised his name wasn't Yoda.
Is he a clone?
No.
We're gonna have to watch it.
Yeah.
Alright. Thanks, bud. One of my little monkeys. One of my little monkeys. Alright. Let's make some connections real quick. Alright. So, I believe, if I'm not mistaken, I don't know if these saved the actual address from the last time. Cisco. Did it save the address from yesterday? No. Okay. Whatever. Well, let's go ahead and assign some addresses to these real quick. Let's get Larry an address real quick. Suited. Alright. And Mr. Switchaboo. Alright, switch. You don't have to do anything. You can just be a switch, because we're not going to do anything to you. So we got Mr. Switch. Let's come over here to some packet captures. And let's ping pin.0.0.2. Alright. We'll let it send a couple packets real quick. I think that's fine. Let's go back to the packet capture. Alright, and we can stop it. So what this is just showing, guys, is just some of the actual packets. Well, it's showing all the. It filters out some of the other ones, but it shows primarily all most of the packets that PC1 has just sent through its actual wire. Okay, so this is all the packets that went physically through this one wire right here. So we have some DHCP messages coming through. We got some STP messages coming through. Here's some ARP. Who has 10.0.2? Tell 10.0.1. So here's a couple of our first, and here's that FFFFFF destination address, guys. Okay. Is the source, okay? So this is where we're getting it to some of the MAC. So Ethernet layer 2. So here's layer 2. All right, it's telling you. Here's the broadcast address. It's just blasting it out there. All right. And then here's the actual. This is representing the NIC, and this is the MAC address on that NIC right there. All right. And if I'm not too much in the way. You guys can still see that. So I'll put that back up. And then here's the ARP request right here. and then it's showing the actual protocol. All right, and then yeah, I'm not too much in the way. The sender MAC address, the sender IP address, and then the target MAC, and then the target IP address. All right, and then once we get to the ICMP, all right, that ICMP message, that's that actual ping that we sent through the wire. So when we gave the command ping, and then we gave the IP address of Mr. Larry, Mr. Larry's IP address. All right, let me make the size a little bit bigger. So Mr. Larry is 10.0.0.2, and Mr. Bob over here is 10.0.0.1. All right, Mr. Switch ain't got no IP addressing. Okay, again, this image is a layer 3, but I'm using it as a layer 2. I don't have to assign it an IP address. I don't have to mess with anything. It's going to do exactly what a layer 2 switch is generally going to do. Okay, well, it is going to do what it's going to do. So here's that ICMP message. All right, protocol, ICMP. All right, echo, ping, saying it right there, request. So here we go. So there's that layer 2. It's looking for some destinations, and let's go to the Internet Protocol version 4. So IPv4. So Internet Protocol version 4. IPv4 source right here. Destination right there. All right. So it's going to go through. It's going to be doing some of its source, destinations. It's looking at all the information it needs to know to get over to Mr. Larry. All right. And then over here we have the this is the reply. So this one was the request, and then this is the reply. All right. So source 10.0. Destination though. Destination is now Bob. The source though now is Larry. All right. And then we pinged it a couple times. And then again, it's still sending some STP messages through its wire. These messages are continuing to go through this wire. All right. It's sending, again, here's some more ARP requests, some address resolution protocol. All right. All these messages are continuously being fed through here. So over here, let's do show ARP table. Let me get a exit. That way I can get some context sensitive help real quick. Show get some context sensitive help. We're gonna do some.
They came from Brazil.
doesn't have any. This switch doesn't have any. Oh, you know what I'm doing wrong? Yeah. Come on, buddy. Use your head. There we go. Show MAC address. Okay. So the switch itself, through the ARP messages, has dynamically learned the MAC addressing of Mr. Bob and Mr. Larry. All right. Come over here. Brakes for a second. Hold on. Go. Sometimes it breaks. Hold on. I gotta get Cisco Model Lab not to hate me for a second. There we go. Woo. Sometimes it breaks on me. Let's look at the MAC address. Okay. Let's write it down real quick. So we have 52 semicolon 54 semicolon 00 dash 0A semicolon 92 semicolon 98. So that's the MAC address, okay? Mac, Mr. Mac. Come over here to Mr. Larry now. Let's go get his MAC address real quick. Alright, here's his MAC address. So, Mr. Larry is 52 54 00 0A 39 5 Echo. Okay. Right. Here. Show Mr. Mac and me. Alright. So on Gigabit Ethernet 0-2, so that's this interface port. That's Larry over here, and it's learned it dynamically, okay? And then 9298 out of Gigabit Ethernet 0-1, it knows it dynamically, again, it's dynamically learned Bob's MAC address. So this is layer 2, guys, okay? And that's pretty much what we just reviewed. All right, layer 2 PDUs, what we just covered in chapter 2. Now, chapter 3 is going to get into a little bit more of a colon, semicolon. My English is so awful, I know. That's why I'm in English class right now. I'm learning that stuff. My English teacher's already yelled at me a couple times. So yeah. So I hope, yeah. I feel like this was a pretty good review. All right. Again, tomorrow, guys, we'll be back at 5 o'clock Eastern Standard Time. Come join me tomorrow. We're gonna do the exact same thing. We're gonna go into the Pearson test exam. We're gonna review chapter 2, what we just did today, but we're gonna be doing it on the Pearson program. Okay. We'll go through some of that, and then we're gonna jump into chapter 3. All right. Chapter 3. Let me give you the topic for chapter 3. Chapter 3 is the fundamentals of WANs and IP routing. Okay, so we're gonna start. We're gonna start talking about IP routing and then wide area networks. Okay, so this should be a fun topic as the topics, as the chapters progress, it's going to start getting into higher level. So we got to think, we're starting low level. That's what we're at right now. We're at layer, we're talking about, you know, the cabling and the fits and whatnot. Low level. As we climb up the TCP IP ladder, you know, IP routing, transport layer, HTTP, SSH, you know, we'll get into the CCNA level. It briefly talks at the end about APIs and controllers and stuff like that. Again, that's higher level stuff. And again, guys, I'm thinking about adding another stream in addition to this stream, possibly early on in the day, to start covering the actual DevNet Associate certification as well, guys. So I want to thank everybody tonight for joining me, and you know, I'll see you guys all again tomorrow. Again, guys, from my house to your house, love you all. Thank you all for coming, and I'll see you all tomorrow. Have a good night, everybody. Joe's out.